There's one detail that most people don't notice when they look at humanoid robots. Not the legs, not the body, not the cameras. It's precisely this detail that determines whether a robot will ever be able to replace a human being on a production line, in a nursing home, or in the kitchen. And it's precisely around this detail that one of the most expensive technology races in history is now unfolding. The company that solves this problem first will gain not just an advantage, it will gain a market that experts are already calling the largest in the history of industry. We're talking about the robot's hand. Recently, the company 3’s unveiled a robotic hand with 25 degrees of freedom. This manipulator is capable of inserting a USB-C cable, zipping up a zipper, holding a glass, and carefully pouring water. For robotics, this is a serious step forward. But almost immediately after this demonstration, Tesla made a statement that instantly spread throughout the community. The Optimus hand wouldn't just match these capabilities, it would surpass what the world had just seen. This isn't just words. Tesla has backed it up with action. The company published a video of the teardown of the original production lines for the Model S and Model X at the Fremont factory. The whole process took just 46 days. The freed-up floor space is being handed over to production of third-generation robots, Optimus Gen 3. Many analysts have called this decision a trillion-dollar gamble. Tesla is knowingly sacrificing stable revenue from car sales to bet on what Elon Musk considers the most important product in the company's history. What exactly makes the Optimus hand potentially the most advanced one in existence? The answer lies hidden inside, in the drive system. Both Tesla and 3’s are moving away from traditional robotic hands, which use gearboxes with enormous reduction ratios from 100 to almost 300 to 1. Gearboxes like that provide torque, but they create friction, backlash, slow response, and unnatural stiffness in movement. Tesla is developing a quasi-direct drive architecture, specially designed high-torque electric motors with a reduction ratio of around 8 to 1 on most of the finger joints. This dramatically improves back drivability. External forces get transmitted directly back to the motors instead of being absorbed by heavy gears. If a finger touches an object or runs into unexpected resistance, the motors instantly detect the change through electrical current and adjust the grip force almost instantaneously. The movement becomes smoother, faster, safer, and significantly more human-like. In terms of mechanical dexterity, Optimus is also aiming for the lead. The newest hand is designed with 22 actively controlled degrees of freedom, plus 3 additional degrees of freedom in the wrist, 25 actively driven joints per arm in total. The fundamental difference from competitors: Tesla is betting on active control of every key joint instead of passive spring mechanisms. This allows it to simultaneously coordinate finger position, grip force, wrist orientation, and movement trajectory. The robot doesn't just pick up an object, it rotates parts within its fingers, repositions tools mid-task, inserts electrical connectors at different angles, tightens screws, and carries out precision assembly work that used to require skilled workers. The entire mechanical structure of the hand has been redesigned from scratch. Tesla uses a tendon-driven architecture inspired by the structure of the human hand. The electric motors are located in the forearm and control finger movement through 44 high-strength tendons. This significantly cuts down on the weight of the hand itself, reduces inertia, and allows for faster acceleration and more precise stopping. During sudden changes of direction or delicate manipulation, the fingertips stay stable without extra vibration. The lighter build also reduces energy consumption. The motors no longer need to repeatedly accelerate heavy actuators mounted directly in the fingers. Touch is no less important. Optimus uses soft polymer pads on the fingertips with built-in high-resolution tactile sensors capable of measuring both pressure and shear force. Pressure sensors tell the robot how firmly it's holding an object. Shear sensors pick up microscopic slippage before the object even starts to fall. If Optimus is holding a fragile glass or inserting a thin connector, the control system automatically increases the grip force just enough to prevent slippage without crushing the object. A human being makes this adjustment unconsciously, thousands of times a day. Giving a robot that same ability is one of the key steps toward genuine human-level manipulation. Durability is critical for industrial use. According to Tesla, the wrist joints and tendon mechanisms are rated for more than 2 million working cycles under load. The whole hand is being designed with IP68 protection. It can withstand dust, water, industrial oils, cleaning chemicals, and harsh production conditions. This isn't a lab prototype. It's a component meant for continuous operation on an assembly line. But maybe Tesla's main advantage doesn't lie in the hardware at all. Every Optimus deployed at Tesla's factories becomes part of a massive artificial intelligence learning network. By performing repetitive manufacturing operations, the robots continuously gather visual, tactile, and motor data that improve the neural networks. A skill learned by one robot can be passed on to the entire fleet. This approach is hard for competitors to replicate. Few companies simultaneously operate both advanced humanoid robots and large-scale manufacturing within a single organization. More than 1,000 early Optimus units are already working inside Tesla's facilities, gathering real operational data and training the AI systems that future versions of the robots will rely on. Gen 3 will get a 3 kilowatt-hour battery pack based on Tesla's own 4680 cells, enough for around 5 to 6 hours of operation under typical loads. For a lot of industrial tasks, that's sufficient. But for home use, a fundamental question comes up. A robot helping an elderly person or looking after a kid can't just stop because its battery died. Reliability here is no less important than functionality. Tesla has also applied a minimalist design philosophy inspired by SpaceX's engineering approach. Most of the complex mechanical systems are hidden beneath a smooth housing, fewer visible components, simpler maintenance, greater longevity. This is visually elegant, but it also raises questions about inspection and trust once a powerful humanoid robot ends up inside someone's home. Inside is a new processor, AI-5. Previous systems based on AI-4 showed good perception and reasoning, but they sometimes paused when processing complex situations. AI-5 was designed to fix this problem. According to available data, the chip delivers roughly 5 times the memory bandwidth of AI-4, allowing significantly larger AI models to be loaded and run almost instantly. Instead of thinking before every action, the robot is meant to react more like a human reflex, continuously adapting to changing conditions without interrupting the task. This is a central piece of Musk's long-term vision. Optimus is meant to handle tasks ranging from factory assembly to elder care and childcare. A robot that never gets tired, never misses a dose of medication, and reacts instantly to emergencies could, in theory, become part of the answer to the global shortage of caregivers, a problem that's only getting worse as populations age in many countries. However, with the mass deployment of robots in homes, fundamentally new risks come up. Unlike a smartphone or even a self-driving car, a 70-kilogram humanoid interacts with people directly. Any software bug, hardware failure, or cybersecurity vulnerability could have immediate physical consequences. If millions of robots are running on a single shared software architecture, one breach could affect the entire connected system. That's precisely why security and protection against cyber threats may turn out to be no less important than the artificial intelligence itself. Tesla is betting that Optimus will become not just another humanoid robot with an advanced hand, but the first commercially scalable robotic workforce capable of transforming both manufacturing and everyday life. Whether this pays off remains to be seen. But what's happening right now no longer looks like an experiment. If you're interested in following how this race unfolds, subscribe to the channel and hit like. It helps us make more breakdowns like this one.